People at Zoom, can you hear me? And just as important, can I hear you?
Are you asking if you can be heard?
So just about at time. And according to my that's where we left off. Okay. So with polar coordinates, where we have x and y as rectangular coordinates and r theta are the polar coordinates, where x equals r cosine theta and y equals r sine theta. And the unit circle is this exact same formula where the radius is 1. Okay, so we look at the point 3, is that pi over 6? So here's 3 pi over 6, where we have the angle off of the polar axis is pi over 6, and then this distance here from the pole to the point is 3 units long. Now, there's several different ways of talking about that. And you can think of this angle here as being 1 revolution and then coming to that angle. So we make 1 revolution and then we continue on till we hit that ray. Or we could go in the opposite direction. Or we could do the same thing here and go in the opposite direction and pass it up and come back to it. So that would be adding 2 pi or a negative 2 pi to the negative 11 pi over 6. So we have several different ways of talking about this, and then there's even more ways. What if we did, instead of going to this angle, what if we went to the angle that was the polar opposite of it? Okay, so instead of 2 pi over 6, we were going to 7 pi over 6. And so instead of going along that ray, we want to go back the opposite direction. So that would be a negative 3, 7 pi over 6. Where the ray is pointing in the opposite direction we want to go in. And so we apply negative 3, which tells us we're going in the opposite direction of the ray we wind up on.
I thought it was the lava blocker.
It's there.
Oh,
Yeah.
okay.
Okay, so that even has more ways of doing it. So I could have gone a negative 5 pi over 6, which would have wound up down here, and then a negative 3 pi. And then a negative 3 to come back up this way. So there's multiple ways of representing that one point. And I usually suggest the simplest is the best. And you try and have both angles positive, both the radius and the angle positive. But depending upon the problem or the situation you're dealing with, you may want to have the angle be positive and the direction be negative, or you want the angle to be negative and the directions to be positive, so you have this situation. But you still always will wind up at the same place, at the same point. Um, so, yeah, so they talked about going to the angle that's going in the opposite direction. And then that means our radius, if we want to back up this way, rather than go the same direction that this ray is going in. So. Okay, so to plot the point with those coordinates, and then you can find other points that are the same point. It's just their coordinates are going to be different. And so we talk about we want it to be between 2 pi and 4 pi. So that means we want to make a full circle before we come back to it. And that's when the radius is positive. Now we want the radius to be negative. So we want an angle going in the polar opposite direction of this angle, but the angle still be positive. So that means R is going to have to be negative. And then we want the angle to be negative with R being positive. So we want three different ways of writing that. So I always draw the unit circle. And then I'm going to say this is 2 units. The radius here is 2 units, and pi over 3 is this, and so it's here, where this is 2 units. And this angle here is pi over 3. So that makes it 2 pi over 3. Now we want it where R is negative. For R is negative, that means we have to go in this direction, and then do -2 to get here. So the point will be -2 with this angle. Okay, and that angle is, if I add pi to pi over 3, that's going to be 4 pi over 3, because this angle here is 4 pi thirds. So if we're talking about, if we're talking about this angle and this ray, but we don't want to go 2 units along that ray, we want to go the opposite direction. So that brings us back up to here. And then on the last one, took the cap off and I put it someplace. Okay, so we want the angle to be negative now. So that means I want to go in this direction to here. Well, that angle, that's a negative 4 pi over 2. So that's going to be the point. The radius is 2 and theta is a negative 4 pi 2. And, oh, I didn't do letter A. Letter A, let me see if I have another one. I don't know if it shows up very well. Okay, so that means we want to go around once. So, and we want to go in a positive direction, so I'm going to go around once. And then I come to here. So that's adding 2 pi to pi over 3. So that angle there is, what is it? 7 pi over 3. So that'll be 7 pi over 3. So this was A. And which one was B? This one was B. I did it slightly out of order, and this one was C. Yeah. C has this positive radius and the negative angle. B has the negative radius with a positive angle. And A has positive radius with an angle larger than 2 pi. And less than 4 pi, which means you go at least, you only go once around once, and then you go straight to the end. Any questions there? I did it all in one picture. They'll do it they'll do it 3 different pictures. So they'll do letter A. Well, there's the angle first plotted, and then they add a revolution, which was letter A. Oh, I didn't catch that. That is in the wrong place. Fix that very quickly. I really but real quick. I was fixing a lot of these earlier. This is one that I missed. So we just add 2 pi to pi over 3 to get to 7 pi over 3. And so that's just going around once and then winding up back there. And then replace 2 with -2. And so that means we need to go halfway around so that the angle, we get the 4 pi over 3 for it. So we go to the ray going in the opposite direction because our radius is telling we're going to go back up this way. And the last one, we're going to subtract 2 pi because we're going in the negative direction. So minus 2 pi just brings us around this way to here. If we're subtracting 2 pi from this positive angle, then we're going to come back around here to get the negative 5 pi over 3. Is that what I had, negative 5 pi over 3? I don't remember. No, I think I have negative 4 pi. But it is negative. And this actually isn't a 30-degree angle. I mean, a 60-degree angle. This is more like a 30-degree angle. Can't even get their picture right. Okay. All right. Conversion from polar coordinates to rectangular coordinates. Okay. If point P is a point with polar coordinates are theta, then the rectangular coordinates are xy is given by that formula. And if you remember from the unit circle, the x is the cosine. Well, it's the same formula. It's just the radius is 1 for the unit circle. The radius is 1 for the unit circle. So you have the same formula. And just now we're going to have different radii. So the sine and cosine is from the unit circle, and then you just multiply by the radius. Okay. So on this one, sine and cosine of pi over 4. So this is going to be the x is our cosine theta. So the x is going to equal 2 times the cosine of pi over 4. And the y will equal our sine theta. So y is going to be 2 times the sine of pi over 4. And we use those angles from the unit circle that we had been discussing quite a bit. So those angle measures and knowing the trig function of those angles comes in real handy, because I know the cosine of pi over 4 is the square root of 2 over 2, and that the y value, the sine and cosine of pi over 4 is the same value, because it's on a 45-degree angle, which corresponds to y equals x. And that's going to be the square root of 2 over 2 also. So when I multiply 2 times the square root of 2 over 2, I just get the square root of 2. So x is the square root of 2, and y is the square root of 2. So the point 2 pi over 4 is its coordinate point. I mean, its rectangular coordinates is the square root of 2 comma square root of 2. Those two give me the same point, provided the units are the same. So they're using the same conversion I did. Okay, this is something I didn't stress. I like to, and which brings me back to the fact that I like to graph these things. Pi over 4 is this angle, and going 2 units out is here. So I'm in the first quadrant, so that means my x and y value are both going to be positive. So I can tell what the sign of my x and y are going to be, whether my x or y is positive or negative, by which quadrant I wind up with. If they were saying 3 pi over 4, then that would have been up here instead of over here. So my x would have been negative and my y would have been positive. And so then I can just look at what happens in the first quadrant And then just determine what my sine and cosine are gonna be as far as plus or minus. And so they calculate what the x is, they calculate what the y is. And so the point in polar coordinates is 2 pi over 4, and its corresponding rectangular coordinates is going to be the square root of 2 comma square root of 2 in the first quadrant. But like I had said, if this had been 3 pi over 4, then this would have been a negative square root of 2. Because over here, the x value is negative. And so this would have been a negative square root of 2 over 2 to give us the negative square root of 2 for that one. All right. So I'm going to look at a circle with radius 2. So I always go back to drawing this. And then a negative pi over 6 is going this direction from the polar axis. And so this would be a negative pi over 6. But my radius is negative. So that means I want to go in the opposite direction of this angle, which is over here. And I want to go negative 2 along that. So, so this is the point, negative 2, negative pi over 6. Now in this quadrant, I know my x is negative and my y is positive. In this quadrant, it's the opposite. The x is positive and the y is negative. But over here, the x is going to be negative and the y is going to be positive. The reference angle here is just pi over 6. So I'm going to find the cosine of pi over 6, and I'm going to find the sine of pi over 6, and then just change the sign to be the sign of that number to be appropriate for this quadrant. Okay. Cosine of pi over 6 is the square root of 3 over 2, but it's supposed to be negative over here, so it's going to be negative square root of 3 over 2. And the sine is 1/2, and it's positive over there. So I'm going to use negative square root of 3 over 2 for the cosine, and positive 1/2 for the sine in the formula. Now I'm still going to be multiplying by a negative 2.
I'm a little bit lost here. So the negative 2 then, tell me why it's not positive. It would be positive if we moved it to, what about with theta?
Well, theta is a negative pi over 6.
Okay.
So that's this right here. But the radius isn't going 2 units, it's going a negative 2, which means we're going to go in the opposite direction.
Okay, all right, so across, not down. All right, I got it. Got it. Thank you.
Let's see how they do it, because I'm understanding what's going on here. And I would just multiply the things out and make sure that my x is negative and my y is positive. And so the point lies in the second quadrant. They didn't show the picture. Do they have the picture? No, they don't. Okay, so it lies in this quadrant of the rectangular coordinate system. And so the coordinate x will be negative, the y coordinate will be positive, substituting -2 for, okay. So they're gonna go ahead and use negative pi over 6. The cosine of negative pi over 6 is the square root of 3 over 2. And the sine of, okay. And so they get a negative square root of 3, which is supposed to be negative. Okay. Yeah, because we want to do the sine and cosine of this angle, and I went and did the sine and cosine of these angles and then changed them according to where they wound up. But we need them to have the sign of negative. So this would be a -1/2 down here. All right. And then the sign of pi over 6, negative pi over 6 is a positive 1/2, and then a positive a negative 1/2. Yeah, because the y value is going down here. But we're multiplying it by a -2, which makes it a positive 1. So that point there is negative square roots of 3, 1. So you have the rectangular coordinates are 0, 1, 0, 2. So I look at the graph. I always like to look at the graph. They don't always look at the graph. I like to look at the graph. I like to look at pictures. Because they help. Pictures never prove, but they help. Okay. So I'm going 2 units, and this is the point they're talking about. So what in polar coordinates, what's that angle? What is theta? What's theta? If we're doing, what's this angle? Okay, so I'm here. What's this angle? It's an easy angle. What is it? It's one of the quadrantial angles. You have 4 quadrantial angles. That's this angle here, this angle up this way, this angle that way, and this angle down this way. 0. This is 0 degrees or 0 radians. So theta in this case is 0. And how far do we go along that ray? 2. So this is the point 2, 0 in polar. In polar coordinates, it's the point 2, 0. Uh-oh. I was thinking the point 2, 0. It's not the point 2, 0. It's the point 0, 2, which is up here. So we're talking about this angle, not the polar axis angle. So what is that angle? No, that's not 0. 0 is over here. So yeah, 90, which is pi over 2. Polar coordinates, we almost always use radians. So 90 is pi over 2. And how far did we go along that ray? 2. Correct. So theta is 2 and pi over 2, and the radius is 2. So in polar coordinates, it is what I'm calling r theta. So, and they'll go through they're going to go through the process here of asking about the quadrantial angles. Okay. Point lies on the positive y-axis, so that's pi over 2. And it's 2 units away from the origin, which is also the pole. So that's its radius. And so we get this polar coordinates. Other possible representations. Okay, so you have more than one way of showing. So if I went, instead of going the positive direction, if I went in the negative direction, and then I had my radius go the opposite direction of that ray, then you have -2, -pi over 2. And then I could go around the circle once and then come to that angle. And that's 5 pi over 2. So 2 pi over 2. So yeah, there's several different ways of writing that ordered pair, that ordered coordinate. But keep it simple. So if it's on one of the axes, it's on the positive x-axis, then the angle is 0. And if that's a units long, then it's a0 in polar coordinates. It looks exactly the same as the rectangular coordinates. If it's on the positive y-axis, which is a problem we just did, what the point is 0a, but in polar coordinates it's going to be a pi over 2. If it's on the negative x, on the negative side on the x-axis, then the angle there is pi. Our x value in the coordinate system is negative, but in polar coordinates, we're going to write it as a positive number. Unless there's always more ways of writing it, so it is negative, but it's simple. And then in this case, the point is on the negative portion of the x-axis. So that part, this ray is 3 pi over 2. So that's that angle, 3 pi over 2. And we're going along that a units, even though the y coordinate is negative. Because we almost always want to be going in the positive direction. But sometimes, depending upon how the problem works out, you may want to go along that angle, but you need to go in the opposite direction. So, and that comes up more clearly when we do graphing polar equations. Okay. Now, if the absolute value of x and y are the same number, then it's one of the 45-degree angles. It's either pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So it just all depends on which quadrant we wind up in. 3, -3 is over here. So that means we're either gonna go, this ray here is either from this angle or this angle. It just depends if you want to represent it as a positive angle or a negative angle. So I'm going to say theta is 7 pi over 4, rather than doing the negative. They may end up doing the negative, which is a negative pi over 4. But whether they use 7 pi over 4 or negative pi over 4, R is going to be positive. So now we need to find out what R is. Well, here I have a right triangle, and R here is the hypotenuse of that right triangle. All right, this distance here is a -3, and the negative just means we're going down. And this distance over here is a +3. So we're going to have, because I know x squared plus y squared being square rooted gives me the R. And they almost always look at it this way. X squared plus y squared equals R squared. And then when you take the square root, we want the positive square root. And so 3 squared, we have 3 squared plus 3 squared being square rooted, which winds up being 9 plus 9, sorry, which is the square root of 18, which winds simplifying the square root. That means you pull out any factors that have perfect squares. 18 is 9 times 2, and 9 is a perfect square, so that becomes 3 square roots of 2. So R is 3 square roots of 2. And theta is 7 pi over 4, or I can write it using the other representation of that angle. 3 square roots of 2, comma, negative pi over 4. Either way is correct. Either way, it's within one revolution of 2 pi, either positively or negatively. So either way is and then there are other ways to represent that angle or that point, I should say. And a lot of times what the textbook does, if you wind up in the 3rd or 4th quadrant, they deal with negative angles. And if you're in the 1st and 2nd quadrant, they deal with positive angles. It's just what the author is comfortable with. For my liking, I like to always use positive angles and positive radii as much as possible. Plot the point XY so you know which quadrant it's going to be in, and that's what they did. And so here they're going to say it's a negative angle. All right, determine the distance R from the origin. So they're using the Pythagorean theorem or the distance formula. And they got this 3 square roots of 2. Determine theta. Okay. So what they end up doing, and this is usually the formula we want to use. We know X and Y. So X and Y is 3 and -3. So we're gonna do the tangent inverse of -3/3, which is the tangent inverse of -1, right? Tangent is negative in the second and fourth quadrant. And I think if you punch this in the calculator, it will give you, it gives you the fourth quadrant, not the second quadrant. Because I think the calculators are programmed that inverse tangent gives you numbers between -π/2 and π/2. And if you do tangent inverse of -1, you'll get a decimal number. And if you divide that decimal number by pi, you'll get a decimal number that is something times, and so that'll be the number times pi. In this case, you'll get 0.25 or some number close to that. And so that's our -2.5. And that's a -1/4, and you multiply it by pi. Because if I divide pi out, I still have to multiply back in. So I'm taking pi out of the decimal number so I can write it in as a simple pi. And that's basically what they did here. Okay. So they get -π/4. And so a set of polar coordinates for the point 3, -3 is square root of 3, 3 square roots of 2, -π/4. And then they give you other possible representations. And this is the angle I was going for in the first place, until I realized, yeah, they if it's between, it always depends upon the function they're using with the inverse. And with the inverses, you have specific domains to work within. So the range are specific ranges. Okay. Now, find polar coordinates. Okay, so doing the same thing. It's going to be in the third quadrant. So both x and y are negative. That means tangent will be positive in that quadrant. And we do the same process of finding r, which is the distance from this point and the origin. So that's going to be this -2 squared and -2 squared. You add them together and take their square root. All right, so please don't fall into this mistake of squaring a negative number and getting a negative number. Square a negative number, you always get a positive number. So please, there are people who still are doing this. So I don't know if it's anybody in this class, but I still have people doing it. And so you wind up with the square root of 8, and the square root of 8 is 2 times the square root of 2. So that's what r is. So now we just need to figure out what the angle is. And so we're going to do inverse tangent of y over x. So that's going to be the inverse tangent of -2 over -2, which is the tangent of 1. And it's going to give me an angle in either the first or fourth quadrant. But we need to wind up in the third quadrant. So But since I'm taking the tangent of a positive number, that's gonna put me in the first quadrant. So all I'm gonna have to do is add pi to it to get into the third quadrant. So, and that's what they're saying here. They're saying the exact same thing I said. Since -2, -2 is in the third quadrant and the inverse function gives an angle in the first quadrant, since we're taking tangent of a positive number, or we're taking tangent of a negative number, it would be in the second quadrant. So we just need to add pi to the angle we give, and that'll put us, because if it's 45-degree angle and I add pi to it, I wind it back down here where I need to be. 180 degrees from the direction it gives me. So we end up adding pi to pi over 4, which is pi over 4. So my point is in polar form is 2 squared roots of 2, comma 5 pi over 4. Next slide. Oh, not yet. And they always give possible other representations. And this is using the negative angle. And this is using the pi over 4 they give that tangent of 1, inverse tangent of 1 gives us, and we need to go in the opposite direction of that angle so they make the radius negative rather than adding pi to pi over 4. So here are things to look at. If you know what quadrant you're going to be in, then you need to determine, am I going to add pi to the inverse tangent, or am I just going to use the inverse tangent? Okay. If you wind up in the first quadrant or the fourth quadrant, the first and fourth quadrant, you're just going to do tangent inverse of x over y. Because that will make you wind up in the correct quadrant. But if your point is not in the first or fourth quadrant, if it's in the second or third quadrant, I need to add pi to the inverse tangent to get me to the proper angle. Because if tangent is negative, if the angle is in the fourth quadrant, that means I'm going to need to wind up here in the second quadrant, so I'm going to add pi to it, so it'll take me over there. Because this is where my point is, and that's how they do this. And if tangent is positive, if the x over y is positive, but you know you're supposed to be down here, then your tangent will give you, your inverse tangent will give you an angle in the first quadrant where you add the pi to it to take you back over here. I would have done these in a different order than they did. I would have done A, B, D, A, C, D, B. Because these two are related to each other, and these two are related to each other, because tangent is going to have the same sign in those two. Just like the tangent in these two, for these two, are going to have the same sign. It's just which quadrant are you going to wind up in? Okay. Converting from rectangular coordinates to polar coordinates. Well, if you know X and Y, then you use the Pythagorean theorem to solve for R. So you get the radius. And then Y over X is the tangent of the angle. So you do the inverse tangent of X over Y to get your angle. And if Y equals R, then that's something we were already talking about. If Y equals R, that means that X is 0. Then you're on pi over 2, that angle pi over 2. And if R equals a negative Y, then theta is 3 pi over 2. And if that's if X is 0. If X is not 0, then we follow that. And if Y, do they have other angles for Y when Y is 0? Because then if R equals X, then you're talking on the 0 angle. And if R equals a negative X, then you're talking it's on pi. All right, plot the point XY shown from the examples 5, 6, and 7. Okay. Oh, these are the steps. Okay. And so we've already had examples 5, 6, and 7. So these are the steps they're using. So you plot the points to determine which quadrant you're in. If X equals 0 and Y equals 0, use the graph to find R. And also theta. And if X and Y are both not 0, then you find R by using the Pythagorean theorem or the distance formula, whichever you want to look at it as. And if X or Y is 0, then you use the graph to determine theta. But if both X and Y are not 0, you notice the quadrant in which the point lies in. If the point is in the first or fourth quadrant, then the angle is the inverse tangent of X over Y. So whatever you get for X over Y, the inverse tangent of X over Y, that's the angle. And if the point winds up in the second or third quadrant, then you're going to add pi to the inverse tangent of Y over X. Okay. So this states those ways of finding the polar coordinates more succinctly than they had previously. Oh man, I went through the slides earlier today to try and fix those problems. And I missed a couple. Here we go. So we want to transform the equation R for cosine theta from polar coordinates, because it's in polar coordinates right now, into rectangular coordinates. Well, put it down. I can't find it. I put it in my pocket. Now, we want to use the fact that R squared equals X squared plus Y squared. And we want to use the fact that R cosine theta equals X, and R sine theta equals Y. Well, I don't have any sine theta here. So, but I don't have R squared and I don't have R cosine. So if I multiply both sides by the same number, I'm not changing what R and theta are. I'm changing what the expression looks like. So this becomes R squared equals 4 times R cosine theta. Now I have R squared, which is X squared plus Y squared. And I have R cosine theta, which is X, so this is 4X. And what I need to do is, let's see. Well, what they're going to ask you to do, because we want to write it in a certain way. And so I'm going to subtract 4x from both sides and get x squared plus 4x plus y squared equals 0. Oh, it's not plus. Sorry about that. Because I'm subtracting 4x from both sides. That's going to be a minus 4x. Now what I need to do here, because I want to write this in the form of a circle, the equation of a circle. The equation of a circle is x squared minus h.
Question.
Yes.
So how did you get the 4x? Where's the 4x from?
What is r cosine theta?
Oh, okay, so you have to do the cosine.
Yeah, r cosine,
Yeah.
because it has cosine in it. If it was sine here, then that instead of being a 4x would be a 4y. And the equation of a circle is written this way. So that what that means is right here, I need to complete the square. The y squared means the h value here for the y is 0. So I actually, that's a k, not an h. Because that gives the center of the circle hk. And whatever r is over here, r squared is over here, you take the square root of it, that gives you what r is. So I want to complete the square. X squared minus 4x. I want to be able to add something here so it'll be a perfect square trinomial. To do that, I take the -4 and I take half of it, and I'm going to square it. That's what I'm going to add here. So the half of -4 is a -2, and I'm gonna square that, so that means I'm gonna add 4. If I add 4 here, that makes it a perfect square trinomial. And so if I add 4 in here, I have to add 4 over here as well. Because otherwise I'm changing the problem. I have to, if I add something to one side, I have to add it to the other side of the equation. So this becomes x squared minus 4x plus 4 plus y squared equals 0. All right. And the reason I do these steps this way, exactly this way, is because what I squared here was a -2. So this is a perfect square trinomial, which means I can factor it to x minus 2 being squared. The -2 corresponds to the -2 here. If this was been a +2, in other words, if this was +4 instead of -4, then this would have been a plus sign. So this is going to be x minus 2 squared plus y squared equals 0. My h value here, the x coordinate of the center of the circle is 2. The y coordinate for the center of the circle is 0, right? Because I can write y squared as y minus 0 squared. I can always add or subtract 0. It doesn't change what it is, it just changes what it looks like. So that means my y value is 0. Oh, I forgot that I added a 4. I had to add the 4 on the outside. I didn't do that. And so this means that r squared is 4, so that means r is 2. And in this case, when we're talking r, in this case, it's always going to be positive. So when we take the square root, we want the positive square root. So in this case, r is a positive 2. So it's a circle centered at 0, 2. I mean at 2, 0 with a radius of 2. What does that look like? I'm going to draw my circle first. Ah, yes, I did it. Okay. And so this is the center, and it's at 2 on the x-axis. So that's what the circle looks like. And identify the graph. Well, the graph is a circle. They didn't ask you to graph it, but I like to graph it. Even though my graphs look horrible sometimes, a lot of times, most of the time. Okay. So now we're going to go through and watch how they're going to do it the same way. I don't know if they're going to show the graph or not. I can't remember. So multiplying both sides by r makes it easier to apply the formulas. So we know that r is x squared plus y squared, and r cosine theta is x. And so they get the same thing I had gotten. And then they're going to subtract 4x from both sides. This is the equation of a circle. And then you proceed to complete the square to obtain the standard form of the equation of a circle. I knew that's what they wanted to do, but I couldn't remember how they said it. Anyway, so we're going to subtract 4x from both sides, but I'm going to group my x terms together because I need to complete the square here. Here I don't need to complete the square because that tells me that the y coordinate is 0. If it was just x squared plus y squared equals some number, then I know that it's centered at 0.
Sir,
Yes.
is it okay if I can talk to you after class?
Yes.
Okay, thank you.
Completing the square, they don't show you how to complete the square. They assume you already know how to do this. And then this is a perfect square trinomial, which factors to x minus 2 being squared. So the x coordinate of the circle is 2 and the y coordinate of the circle is 0. So in standard form, the equation of a circle with a center at 2, 0, and a radius of 2. They graph it? No, they do not. Now we want to transform this from rectangular coordinates to polar coordinates. Well, I know what x and r, x and y equal, x and y, x equals r cosine, and y equals r sine. So we put those in place. So 4xy equals r cosine times r sine. And then you have the 4 being multiplied in there as well. I can factor the 2 r's out as r squared, because I'm just multiplying here. This is just straight multiplying. So I'm doing r times r, which is r squared, and then cosine times sine. And this part here, almost looks like a trig identity. But I'm missing something in front of this. But if I split 4 as 2 times 2, and I can use the commutative property to rewrite this as 2r squared. Well, let's just pull up what they say. 2r squared, 2 cosine theta sine theta. I still have 4, 2 times 2, but I just split it up. Mathematics is taking things apart and putting them back together again in new and interesting ways. Now I know 2 cosine theta sine theta. That's one of the double angle theorems formulas. Isn't that cosine 2 theta? Yeah. And at this point, I would divide through by the 2. I don't think they do that. Yeah, I would divide through by 2 and say r squared sine of 2 theta equals 8. And I would go one step further and divide both sides by sine 2 theta and get 8 times cosecant 2 theta. But that's me. But this survives. If you get this type problem on the test, this is as far as you need to go. Okay. Polar equations and graphs. This is the fun stuff. Okay. Okay, so we're going to identify and graph polar equations by converting to rectangular equations, test polar equations for symmetry, and graph polar equations by plotting points. Plotting points to graph polar equations is generally the easiest way to go. On a test, I will need to see that work of finding those points. Putting a number in for picking an angle and putting that into the equation to find out what r is, where that angle. So, yeah. All right, so, and then testing for symmetry. It's useful, but not necessary. what was it for? Identify and graph polar equations by converting to rectangular. All right. So an equation whose variables are polar coordinates, it is called a polar equation. The graph of a polar equation consists of all points whose polar coordinates satisfy the equation. That's the same definition of in the rectangular coordinate system. If it's a rectangular equation, then the graph of a rectangular equation consists of all the points whose rectangular coordinates satisfy the equation. So that you're used to doing that, but we don't talk about it specifically as specifically as we do with polar. Because we don't normally work with polar. So identify and graph the equation r equals 4. The radius is 4. What does that look like? Radius is 4. Does it specify an angle? So everything that's the radius is 4. What does that look like? Yes.
Just the circle.
Yes. It's just a circle. Convert the polar equation to rectangular equation. Well, r equals 4. R squared equals 16. If you square both sides, okay, squaring both sides, you get r squared, which brings in the x and y. So this is x squared plus y squared. So this is the equation of a circle centered at the origin where the radius is 4. Boom. And they squashed this graph a little bit this way, so it's slightly oval here, not ellipsoid. So, but on the there it's correct. Well, anyway, that has to do with the angle. Okay. Because every point on this curve is 4 units away from the pole. So yeah, it's just a circle of radius 4, centered at 0, 0. Now, theta equals, is that a 3 pi over 4? Yes. Theta equals 3 pi over 4. Well, three pi over 4. That's this ray, but they're not designating the radius. So the radius could either go in a positive direction or the radius could go in a negative direction. So it's a straight line going through the origin or through the pole. And it's at a 45-degree angle. One of the 45-degree angles. So clear picture. Take the tangent of both sides. So x over y equals -1. Why do we want to take the tangent and get that? Okay, so x and y equal each other, or this is, if I multiply both sides by x, I get y equals negative x, and that's what this line is. This line here, get off of there, is y equals negative x. There they did. And so, not too far off from where they drew the picture. And so this is the line, theta equals 7 pi over 4. So they're not designating a radius. So radius could be positive, which is going that way, or the radius could be negative, which is coming this way. And there we have. Okay. Now we have r sine theta equals 3. So if I write this as a, in the rectangular coordinates, r sine theta is y. So this is just the line y equals 3. It's a horizontal line. Y equals 3. So it's going to be tangent to the circle r equals 3. So we have the vertical line, the horizontal line that is 3 units away from the pole, or it's along its entire length, it's 3 units away from the polar axis. Questions on this? And so the next one is going to be r cosine theta equals negative 4. So you just replace r cosine theta with x. And so that's x equals a negative 4. So that's a vertical line 4 units away from the origin, or 4 units away from the pole. So it's a line that is tangent to r equals 4. Remember what tangent means in terms of lines and circles is there, it touches a circle at exactly 1 point. Excuse me. All right. And there we go. All right, let a be a real number, then the graph of the equation r sine theta equals a is a horizontal line that lies a units either above or below the pole. So if a is negative, it's below the pole. If a is positive, it's above the pole. And the same thing for r cosine theta equals a. Now instead of a horizontal line, it's a vertical line, and it's either vertical to the left of the pole or vertical to the right of the pole. If a is positive, then it's to the right of the pole. If a ends up being negative, it's to the left of the pole. And it's just, they're just vertical lines. Oh. Okay. So now we have this graph. R sine 6 sine theta. R 6 sine theta. So if I multiply both sides by r, then I'll have r squared, and I'll have r sine theta. And I can replace r sine theta with y, and r squared with x squared plus y squared. So we have that. And then I subtract 6y from both sides, so write it in, so this gives me a circle. Whenever you're adding x squared and y squared, you got a circle. But it's not always centered at the origin, and this one is not centered at the origin. And so we complete the square again, so I take half of -6, which is a -3, and I square it. So I'm gonna add 9 here, and I'm gonna add 9 here, and this becomes x squared plus y squared minus 6y plus 9 equals 9. And this is a perfect square trinomial, which factors to y minus 3 being squared. And so this is a circle centered at the point 0, 3 with a radius of 3. And because of the angle that it's shining down on here, it's not going to be a perfect circle. Okay. And so this one is done in the same way. Okay. It just tells me that it's going to be on the x-axis, but it's going to be where the center is on the negative side of the x-axis. So again, we multiply by r, and we replace r squared with x squared plus y squared, and we replace r cosine theta with x. And so this is what we have, and then we add 4x to both sides. And then completing the square here, we're going to end up adding 4, because half of 4 is 2, and 2 squared is 4. So I'm going to add 4 here, and I'm going to add 4 to 0. And so we have this. And this just factors nicely to x plus 2 being squared. So that x coordinate now is a -2, the y coordinate is 0, so it's a circle centered at -2, 0 with a radius of 2, because that's the square root of 4. Okay. So if you have an equation that looks like any of these, you're going to get a circle on either the x-axis or the y-axis. If it's in terms of sine, then it's going to be on the y-axis. If in terms of cosine, then it's going to be on the x-axis. And the circle will be radius a. And depending upon the sign out here, it's either on a positive, A is positive, or A is going to be negative. Because using the same process we used earlier, that's what we wind up with. Okay. Now we're going to look at the symmetry. Symmetric points. And we talk about symmetry with respect to the polar axis. So that's either in the positive direction or the negative direction. Symmetry with respect to pi over 2, so that's both positive and negative directions. because they say the line theta equals pi over 2, so that also extends down this way. So we look at those. So here, if they're symmetric with respect to the polar axis, then they're just going to be negative of each other. If you can write them so that they're the negative of each other, then they're symmetric with respect to the polar axis. So pi over 4 and 7 pi over 4, if r is the same value, then those two angles wind up, because 7 pi over 4 is a negative pi over 4. So if this was 3 pi over 4 and 7 pi over 4, then those 2 points would be symmetric across the polar axis. And here, the two angles differ by pi. So if I do pi minus this angle, I'll wind up over here. And it works down here as well. And then to be symmetric with respect to the pole, that means the two angles either are going in the opposite directions and r is the same value, or the angle is the same in both points, but the r values are opposites. One positive, the other is negative. So that means they're going to be symmetric with respect to the pole, because they're the same distance r from the pole. They're in the opposite directions of each other. Why isn't that? The camera doesn't focus very well, does it? Does not focus well. All right. Test for symmetry. If you replace theta by negative theta and an equivalent equation results, then it's symmetric with respect to the polar axis. If you replace theta with pi minus theta and you wind up with an equivalent equation, usually the same equation, and then it's going to be symmetric with respect to the line theta equals pi over 2. And if you replace r with negative r, or this is important, or you don't do both, you do one or the other. So this is an exclusive or. Okay. Or you replace theta with theta plus pi and an equivalent equation results, then it's going to be symmetric with respect to the pole. What they mean by an equivalent equation is you wind up with the same equation once you simplify things. Now we're going to graph this equation. One second. Let me see here. Very quick. All right, first thing they do is check for symmetry. Replace theta with negative theta. Okay. So the sine of a negative angle is the negative sine of the positive. So this becomes 1 plus sine theta. This angle, this expression is not the same. They're not equivalent. So it's not symmetric with respect to the polar axis. So if the test fails, the graph may or may not be symmetric with respect to the polar axis. So you can't, so this process only tells you definitively if it is. It doesn't tell you definitively it is not. So if it fails, then the graph still might be symmetric with respect to the polar axis, but this this test did not specifically show that. Now, to determine if it was symmetric with pi over 2, then you replace theta with pi minus theta, and you do the difference formula for sine. Sine of pi is 0, so this term goes away. Cosine of pi is -1. And so this is going to be plus sine, because minus and negative is plus. And so it's going to be 1 minus sine. Okay, so they put in the numbers. And so it just works out to be this. It works out to be the same formula. So it is symmetric with respect to pi over 2. Theta equals pi over 2. Now here's the deal with these angles, with these polar equations. They can be symmetric. They can have all of the symmetries. They can have all 3 of the symmetries. So we have to check for the other one by replacing r with -r. Which is not the same formula. So it fails. And so you go ahead and do the other way by replacing theta with theta plus pi. And you end up doing the sine of the sum of 2 angles. And so the sine of cosine of pi is negative. And the sine of pi is 0. So the cosine theta sine pi goes away. And this becomes negative sine, which gives us 1 plus sine. So this test fails. So the graph may or may not be symmetric with respect to the pole, but we know it's symmetric with respect to the vertical line, theta equals pi over 2. So next, to identify points on the graph by assigning values to the angle theta and calculating the corresponding values of r. What do they start with? Oh. Yeah, since you know it's symmetric, with respect to this line, so all I need to do is find out this side and then the points over here. So this point would be corresponding with this point, so I just need to find those corresponding angles that go with it. Okay. So fucking hell, that hurt. I had my booster COVID test booster yesterday, my COVID booster yesterday, and my left arm is useless. It hurts like hell. Even just moving my elbow like that hurts up here. And I was useless yesterday after I took that shot. So we have theta, and I'm going to start at negative pi because I only need to do this side of the circle. So negative pi. Let's see what angles they're using. Oh, I see. Okay. So they're not even going to do the 45-degree angle. So then pi over 3 and negative pi over 6, and then 0, and then pi over 6, and pi over 3, and pi over 2. Because the corresponding angles on the other side are going to have the exact same values. Maybe in a different order, but they'll have the same value. So R, what is R? What was it? Oh, damn it. 2 times 2. Is it 2? This is R over here. R equals 2 times 1 minus sine theta. So the sine of negative pi over 2 is 0. And so this is just 2. So, and I usually graph them as I go along. And so the sine of negative pi over 3, what is the sine of pi over 3? Is 1/2, and so it's going to be negative 1/2, because that's in this quadrant, and sine is negative 1 here. And so it's negative 1/2, so 1 plus 1/2. So that's 3/2 times 2, which is 3. So at this angle, it comes out to 3 here. So I'm going 3 units out along this line. And at negative pi over 6, sine is what? No, I was wrong here. That is a negative square root of 3 over 2. So 1 minus a negative square root of 3 over 2 is plus. And so that's going to be 2 plus the square root of 3 over 2, which becomes 2 plus the square root of 3. Which is a little bit past 3. Okay, yeah, and they punched it into the calculator and got approximately 3.7. So it goes a little bit further than that. It's almost a 4. And then at negative pi over 6, that's when sine is a negative 1/2. And so now it's going to be 1 plus 1/2 times 2, and that is 3. Okay. Sine of pi over 2 is a negative 1. So 1 minus a negative 1 is 2, and 2 times 2 is 4. So this is 4. So it comes down here to 4. So it's not that point. And then at 0, sine is 0, and so this is 2. And now at pi over 6, sine is a positive square root of 3 over 2. So now it's going to be 1 minus the square root of 3 over 2 times 2. And so we get 2 times 2 minus the square root of 3 over 2, which is 2 minus the square root of 3, which is approximately, you punch it in the calculator around it, I think they're rounding to 2 decimal places. Yeah, they went to 7.4, and this is the 0.24. 0.24 along this. So if that's 1, that's going to be about here. And then at pi over 2, I mean at 3 pi over, pi over 3, that's going to be along this one. The sine along that is a positive square root of 3. Wait a minute. No, this is what I put that wrong. Yeah. Right, got it. Sine of pi over 6 is a positive 1/2. So this is 1 minus 1/2 times 2, which is 2 times 1/2, which is 1. So this is 1 here. So it's not that point there, it's this point here. And then at pi over 3, that's where we get the 0.24. And then when sine of pi over 2 is 0, no, sine of pi over 2 is a positive 1. And so 1 minus 1 is 0, and 0 times 2 is 0. And so it's back here. And now the angles over here are just going to repeat these values in the reverse order. So this one is going to be the same as that one. This one's going to be the same as that one. This one's going to be over here. And this one's going to be over here. And then this one's going to be over here. And so now we connect those points in order. I'm going to bring my point down to the line I drew. And so if you have polar coordinate paper, which I'm going to post in, what's that called? In Canvas under files, I'll put in a worksheet that has the graph, the polar graph on it. So if you can get that printed up, you can use that. So let me see here. When you plot all those points. And there looks a lot prettier than mine because they had a polar coordinate. They do it all. That's what I need to do. I need to get one of those things and put it up here. And they had this being every pi over 12 here, but that's not necessary. And we're past time, so if you need, and this is called a cardioid. A cardioid because it looks like a heart. And so if you have an equation of that form, then the graph will look like that. If it's in terms of sine, then it's going to be symmetric with respect to the theta equals pi over 2. If it's in cosine, it's gonna be symmetric with the polar axis. So this is a heart standing up and down, either right side up or upside down. And this is a heart laying on its side. Either with the top being towards the negative side or the top being towards the positive side. So, okay. I'm done for today.
Goodbye, sir.
More tests are there, or exams are there in your class? Like,
There's one more class, exam 3,
and the final, and how much is the final one?
40 points.
Perfect. Out of the entire,
Out of the 100% is worth 40.
perfect. I have like a 7 in your class. So,
Well, I have posted grades.
Really? On the first one, it says I have a 20. And on the second one, I think it's a 0, the exams.
I have posted second exam.
I don't know what I
Sure.
shot.
Not exams.
All right, well, I'm the president of chess club. I gotta be there by like 4.
Okay,
The-
All right, goodbye, sir. Have a good, have a good Monday.
Yeah, that.
Are you sure you haven't posted anything?
I may have posted one set of grades, but that's it.
Yeah, okay.
First exam.
Open, they had a open caption movie.
Why are you missing these movies?
Sir.
Yes,
I spoke to you last I want to say last Thursday or Friday, on the 4th of November, about how I was unable to post the second exam. It still isn't open, and I was just wondering if I could get that done now before you leave or anything. That way I got that solid and I have that down. Because I think it's still closed. And haven't been able to post it.
hang on. No, I've opened it up.
It shows you as open?
Yeah,
Huh. Let me check it out.
okay, let me go here. And share the screen. So student view. All right, so make sure you're in assignments.
Okay.
So you go assignments. And let me back up a second here. See where it says over here, show by date or show by type? Click show by.
Yes.
Because then it's under work for exams. 'Cause we have
Oh, I thought I was looking for imported assignments. Okay.
Yeah, so you go here. And there, yeah, you should be able to start the assignment. And
Okay,
once
sir.
you- Yeah, then you choose file, okay?
Okay, sir. Yeah. That's the onus is on me on that one because I was looking at the
Well, you're
imported
the
ones.
only one who has that issue, and so, yeah. I
Okay,
haven't-
already. I'll be posting that right now, so there's no more issue with that. And that's
Because
not
I have
bothering
had
anybody.
some people who've taken the exam and did not post it.
Right.
For the reason you haven't posted it. They can't post it because they don't know where to go.
Right.
I try
Okay.
to be sure about that, but it doesn't always happen that way, so.
Right. Well, I sent it by email, so I'll be making sure to, and that was a long time ago. So I'll just take that PDF that I sent there and put it in there. That way there's no confusion or anything.
There you go, that's the way to do it.
Okay, sir. Thank you.
Because after I graded them, I will repost them up there so you can see all my notes.
Right. Okay. I appreciate it a lot, sir. Thank you.
All right,
Bye-bye.
take care.